So first of all, I would like to thank Kaspersky Lab, this company, for having this chance to speak at such a conference. A couple of words about the company that represents Rosgidro. Roshydro is one of the largest power manufacturing holdings, 38.6 gigawatt, and so most of its capacity is hydro generation, and such unique as Yana-Shushenska hydropower, the largest one in Russia, Volzhska, the largest one in the European part of Russia, and we also have in the far east of the country, we have the renewables and under our management, and also we have some engineering companies and the design bureaus, and we have also teams for implementation of these cyber threat centers. So of course you're aware that power generation is an industry, and not only this industry, but we have other machine building sectors and segments. So we have the substitution program for critical infrastructure. On the one hand, it's a challenge, but it's an opportunity as well to build a system that would fit the modern demands, and we can operate towards the further development of the whole country. So in Roshydro, we have some secrets that I would like to share with you, and so the experience that we have, how to build such a system, and we need to start somewhere, and we need to start, as was the speaker, about this, understanding where we are at the moment. So very briefly about the industrial operations center, security operations center, and now we have been building it over the last 20 years, let's say, by evolution of some of the parameters, and this can be a small system for a small venue and a big one for a big venue. There are several levels of the feed level, the indicators level, controller level, where we have the algorithms, and the top tier level. So this is the interface of working with the user, and also the infrastructure as well. You have the networks and connections, the systems of protecting of the same time zone, so on and so forth. So the key problem of such systems is very true, and the automatization is not a blanket, but more of a patchwork, and where you have different solutions for different parts, and quite often you do not have a possibility to have the intellectual functions, because this venue is not ready for the new technology. And so we have this picture of trends that is everywhere, and we have AI, robotics, automation of transport. So when you have the vehicles that travel by themselves and the trams, we mentioned that as well. So in order to have this migration from this venue that for 20 years somehow drifted towards something new, you will have to apply certain rigid solutions. And if we just take and pull some of the blocks that were used, let's say pieces of the equipment that was from outside of the country or imported, and when we install the Russian manufactured units, so things may not work, and therefore we need to have some security vision of the future. So this has to be a virtualization. So as step number one, to have a better understanding, and this is not just a vision of the future from my side, but this is what we're just doing at every venue that we have. So we have quite enough venues of virtualization and different levels, but we were the first company in the country for the power generation or heat actually generation, and we change the landscape within the company, and we are quite careful about that and thought through. So because we're not just using, so actually it's done within the venue, and nevertheless virtualization is something that pushes us, let's say, helps us make a step forward. Virtualization of the lower level is also coming up, and we need to be prepared, and this is just a non-standard technology, and then traveling or migrating from an automated system into a system that is managed by the person, machine interface, and human interface. So this slide demonstrates a new center for the small power plant production. So here we have the smaller under 50 gigawatts. So this is just so megawatt. Basically, we don't have the chief of this plant. So we have the chief of the shift. So basically, this is manless technology from the standpoint of the functions, and of course the info security is the key parameter here. And thirdly, the system that, in my view, should be introduced everywhere, and the twins, digital twins. And it's not just the construction of the, for example, when we have the walls and ceiling. No, this is the digital twin of this plant and the model where that has all those communications between those units. And so this type of digital twin so changes the implementation of the kind of control system units, and of course we do it in parallel with the actually regular operations of this plant, for example. And of course we do different testing, and of course the digital twins are helpful when we have some hazardous scenarios at play. And so therefore we arrive at the info security, and we have to work hard and understanding how to provide this new system, control system that's using digital twins and the virtual segments, using the right array of tools, highly automated systems. And of course there could be some physical isolation and the conventional methods, and screening, and using some special software, protective antiviruses software. So actually this introduction of this problem. So it's important. So these systems could overlap with the overall system of control, and so therefore we need to create a tool so that the manufacturer would understand and would see not only the incidents but any changes that they have in the system, and also having the problems that their own mistakes. And let's say, how do we find some financing into, let's say, where to find motivation for business? So this is the direct motivation. So when we have the tool, an info security tool becomes the tool of those who control the systems as it's kind of in live mode, when, for example, some screens and some other tools for the personnel that is running this venue. That's very important. And to conclude, kind of building this bridge to the next part of the presentation, not a single technology can be implemented by, let's say, force. So it takes time, and it starts with some pilot operations, and we get the feedback, and when we collect the best practices, and then we have the documents like logbook, what needs to be done, and disseminate this experience. And what are the partners in this process in terms of the safety and security? We have the Kaspersky lab as partners. We're walking it shoulder to shoulder, hand in hand, and kind of being joined at the hip. Over there, we're formalizing the norms and regulations into some guidelines that we put together for this new system, and I'm sure that the next speaker is going to take on the subject.